Well, so this lesson is about understanding the basic concepts that are linked with solving the system of equations under three unknowns. Now, if you logically look into the equation of one of the plane, if I take, let's say, x plus 3y minus z equals to 15. Now, when I plot them on a three-dimensional graph, it basically represents a plane, so something like this. Now, what happened is that now if I have three such equations, now there might be possibility that they cut each other along a fixed point. They cut each other along a fixed point, something like here, or they are something like parallel, which is they're never meeting. Um, or there might be a case that the two of them are meeting, but the third one doesn't meet. So depending upon the case where whether the equations cut each other at one point, uh, so they meet only these set of equation meet at only one point or at no points. So there are no common points between three planes, or there are infinite points. Now, when there are infinite points, actually what's happening is consider this is the plane number one, this is the plane number two, and this is the plane number three, let's say here. Now, what happened is that if they meet along a line, this is called infinite solution. So these all the points on the plane actually is part of all three equations. So I have taken these two equations to demonstrate using something called as row echelon form using matrix method. So we'll solve these equations first using matrix method, and we're going to geometrically interpret it. What exactly do they mean? So let's just begin with the first one, which is x plus 3y minus, I'm just not going to rewrite this. So first thing is that how do we write down row echelon form? So how do we write row echelon form is basically, we're going to just write down these numbers, the coefficient of the matrix, which is like 1, 3, negative 1, 2, 1, 1, 1, negative 1, and negative 2. And this second part is 15, 7, or 0. Actually, this is, if you write down this in equation form, it is x plus 3y minus z equals to 15. 2x plus y plus z equals to 7. And in some forms, you get this directly, or in some cases, you get this directly. So first thing is that what is the standard procedure to go ahead with such particular questions? Now, when you're doing the row echelon form, we use something called as the row operations in order to make, if I divide this, so you got above diagonal elements and below diagonal elements. Now, below diagonal elements, one by one, we are going to make them 0. So the first number that I'm going to make is this 0. Then second is you're going to make this 0, and third one is make this 0. So just remember the order, so in which you're going to make them 0. So first, second, and third. Now, how do we make them 0? What is the logic, or what is the general method of making them 0? So I'm just going to quickly take put them in uh, different rows. This is called row 3, this is called as row 2, and this is called as row 1. Now, in order to make a particular matrix element 0, what we do is we follow the row operations. So now, for example, if I want to make this 0, you could add or subtract a relevant number from the previous row, or you can multiply, use suitable combination to make this 0. Now, what I do is I can simply look at R3, and row 3 is here. I'm operating on row 3, so that comes first, minus row 1. Now, when I do that, my row 1 actually doesn't change. This doesn't change. And what changes is actually row 3, because you're doing operation on row 3. So my two numbers, 1, 3, negative 1, the two rows, 15, and 2, 1, 1, and 7, it doesn't change, don't change. And here what we change is basically the third row. So R3 minus R1 I'm doing. So 1 minus 1 is 0. Negative 1 minus 3 is negative 4. And negative 2 minus of minus 1 is negative 1, and 0 minus 15 is negative 15. So I have made this 0. So now if you look at, the first thing is that you made this 0. Now the next step is to make this 0, this number. So I have to make this 0. And there is a reason behind it. There is actually the reason behind it, which we'll come to know after we get the particular first, second, and third zeros respectively. So now I can do is R2 minus 2 times R1. So when I do that, my R1 doesn't change. And I can say 1, 3, negative 1, and 15. And R2, which is 2 minus 2. So 2 minus 2 is 0. Here it is 1 minus 6, which is negative 5. Then 1 minus 2, because you're multiplying with 2R1 before you subtract. So 1 minus 2 is actually minus or minus 2 become positive 3. So 1 minus or minus 2 is positive 3. And 7 minus 15, 7 minus 30 is 20, negative 23. So this is how you write down the second row. And now the third row, as it is, I'm going to retain negative 15. So our next step is to make this number 0, the number which is out here 0. So for that, I have to use only the second and third row explicitly. So what I can do is I can multiply the row 2 by 4 and subtract 5 times. So row 3 by 4, row 3 by 5 I can do, and then multiply row 2 by 4 and subtract them. So in that process, the first row numbers doesn't change. So this is 15, doesn't change. 0, minus 5, 3, and minus 23 doesn't change. 0, and this becomes 0 because this is negative 20, this is negative 20. And now you did multiply this by 5. So negative 5 and minus 3 times. So negative 5 minus basically 4 threes are 12. So the negative 12. So this is here is negative 12. So negative 5, negative 12 is negative 17. Next is negative 15. So you're multiplying negative 15 by 5 and minus 4 times negative 23. So this answer simplifies to positive 17, which is negative 15 times 5 minus 4 times negative 23. Now, tracing back our answer basically here. So tracing back the equation that we got, now we got negative 17z equals to 17. So that gives us z as negative 1. That's my first solution. And once I got z as negative 1, you plug in the next equation. My second equation actually is here. Second set of equations here. So negative 5y plus 3z equals to negative 23. So if I plug z as negative 1 here, so negative 5y negative 3 equals to negative 23, and this gives you negative 5y equals to negative 20. So that is nothing but y equals to 4. Once I got y and z as negative 1 and 4, 4 and negative 1 respectively, I can plug in my first equation, which is here. So if I plug x equals to, so x plus 3y minus z equals to 15, I can find out the possible value of x, which is x plus 3y, which is 12, minus z, which is plus 1, equals to 15. So actually x is nothing but 2. So what you got here actually is called as a unique solution. So in some cases, what we'll notice is actually let us try the second one, from which we can take down some of the important conjectures. So while taking the second example, we first reduce to the row echelon form. We apply the order of the operations where R3 minus 3R2 we do in order to make this number 0, which is 3. So that results in 0, negative 6, 6, and 2 in the last row. You can just look at the operation. Now I got to make this 1, 0, which is 0, 2R2 minus R1 made by this operation. So you get 0, 3, minus 3, and minus 1. And R3 and R1 remain unchanged because I didn't operate on them. Now we got to make this number 0 in order to come to the conclusion. So what I can see is clearly here it is 3 and negative 6. So I did R3 plus 2R2 in order to get this number 0. Now, what is really interesting is that after you do that operation, here is the general structure. Now, if you get a row echelon form, suppose this is the diagonal number here, diagonal elements, and there are three numbers here, 1, 2, and 3. And these numbers, as you have made them 0. And here you get the row echelon form. So you have some of these numbers. Now, what is really interesting to observe is that if your last row, that is entirely becomes 0, if last row is entirely 0, this row, which is the case out here, we call this condition as infinite solution. So if the last row is all 0, 0, 0, 0, and 0 here, we call this as infinite solution. Infinite solution. Now, in the case of where it is all 0, how do we obtain the general solution? If they ask you infinite solution, now simply means that if this is one plane, this is the second plane, and here is the third plane, let's say. Now, I have been asked to calculate, let's say, what is the general solution? I can't just say, okay, there are infinite solution and leave there. These infinite points are lying on the common solution. So what we do in this case is we take this equation here, which is 3y minus 3z. Now, as you can see that there are infinite solution, and that solution is represented by this line. And so all the general points, if you see, they're all lying along this line. So that's why what I do is I find out equation of this line. In some cases, you will straight away be said that find out the equation of intersection of equation for the line for intersection of these three planes. So in this case, what we do is we take 3z, that is here, 3y minus 3z equals to -1. And my second equation that we are left with is 2x minus y plus z equals to 5. So we use these two equations to find my in general equation, in general solutions. So what we do is we take, let's say, z as, now take a general assumption here. Now I'm writing my equation since I'm confirmed with that, okay, the entire row is 0, hence it is infinite solution. So this is a protocol or rule we follow. If last row is 0, it means that infinite solution. The equations intersect at infinite point, the planes intersect at infinite points. Now, what we do is we write down the general equation. Now, for general equation, it's up to you what you want to write down this parameters in terms of. So let's say I assume z as t. Now, let's say start with z as t. Once I took z as t, I can write down y in terms of t. So which is 3y minus 3t equals to -1. So we get 3y equals to -1 plus 3t. And as a result of this, we get y is -1 plus 3t over 3. So we got y and z in terms of parameter t. And now since I got y and z, I can plug in the first equation, this is this one, to get x also in terms of t. So which is 2x minus y is -1 plus 3t over 3, and plus z is t equals to 5. Now when I take LCM for this, so it is 2x. So this can be written as, let's say, 6x minus uh, plus 1 minus 3t and plus 3t uh, over, if I take LCM of this, so this is over 3 equals to, let's say, 5. Now, when I get the 6x, so this minus t and plus t anyway get cancelled. So you get 6x equals to 15 minus 1, which is 14. So I get x is 14 minus 6, which is 14 over 6. So these are the general answers for x, y, and z. So this is the case where you got the infinite solution. Now there are two other cases where you have these are the diagonal numbers, and below diagonal numbers, I'm just writing here. So these are the two deciders. Okay. Now if my left hand side is 0, this number is 0, and this is non-zero, a simple logic is like 0x plus 0y plus 0z equals to number 5 or 6, 7, something like that. How is it possible? Like, how can you have 0x plus 0y plus 0z equals to 8 or something? It's not possible. So that's why it is called as no solution. Now, in a case where the diagonal numbers, which is like, okay, these numbers, okay, 0, 0, and 0, and here this number. If this is non-zero, this is non-zero, and this is anything, it doesn't matter. Like here in this case, the previous case where we did, this was non-zero number, and this doesn't matter in that case, and this is referred as a unique solution, or the planes are going to cut at one point. So as a summary of this, now if your last row is 0, 0, 0, slash 0, this is infinite solution. If you got 0, 0, 0, and non-zero, this is no solution. And if you got 0, 0, non-zero, and anything, this doesn't matter. This is called as a unique solution. Unique solution. So let's take one more example that is a very favorite type of the IB exam questions. So for this one, first what we do is make the row echelon form, which is 1, 1, 3, and 2. We get 3, negative 1, 2, and 5. 5, 1, 8, and 8. Now make sure you double check each number before you go ahead, because once you make a mistake in any of these numbers, entire working is going to be wrong. So now first step is to make this number 0, which is 5. And I can clearly see that R3 minus I can do is 5 times R1. So when I do R3 minus 5 times R1, what we get is, let's say 1, 1, 3, and 2. The row 1 remains unchanged. Row 2 remains unchanged. And here is 5. Now we get R3 minus 5R1. So that is 0 straight away. Now R3, here it is 1, and here it is 5. So 1 minus 5, it is negative 4. 8 is R3 minus 5R1. So 5 threes are 15. 8 minus 15, which is 7. Uh, and then A minus 10, which is here. So this is the result of the first operation. Now you got to make the second row 0, second number 0, which is R2 minus 3R1 if I do. Now when I do that, what we get is, we get 1, 1, 3, 2 here. We get 0, and minus 1, which minus 1 minus 3, which is negative 4. 2 minus 9, which is negative 7. And 5 minus 3R1, which is 5 minus 6, which is negative 1. And you get 0, negative 4, negative 7, and A negative 10. Our next step is to make this number 0. So I can do simply R3 minus R2, because we can see there are like numbers. So 1, 1, 3, and 2. And you get 0, minus 4, minus 7, negative 1. And you get 0, and 0, 0, and A minus 9. So this is the last row that I'm getting, which is the decider for us. Now, since I have got already the left-hand side 0, okay, so there is no possibility of unique solution. Since already there are, for unique solution, if you see, we got to have 0, 0, 0, non-zero here. So already we got a 0 number here. That means that it is out of the context. So it can't have a unique solution. Now for coming about the infinite or no solution, that will be decided by the value of A. So now if you take A minus 9 equals to 0, which means that making the last row entirely 0. If I take A as 9, then you're going to have infinite solution. But if A is not equals to 9, then this results in no solution. So if A is not equals to 9, so if I take A is something like 7, so 7 minus 9 is negative 2. So what happened is that I get 0, 0 equals to negative 2. That's not possible. So that's what is the case, where A, if I take not equals to 9, then you'll have no solution. The third case is that in case where it has got infinite solution, so when A is 9, find out the general solution and interpret geometrically. So the general solution is that they intersect along a line